Hello, we've been working on this beautiful VR2324 Philips V2000 format, that's these tapes, video recorder. And we got it to go from the position of being apparently completely dead to at least parts of the display working. But we still have some problems, let's go through them. Okay, at one point I was able to set the clock, but not now. And when I press buttons on here, it responds very slowly, so there's a problem in that control panel. But much more importantly, the deck doesn't work. If I hit a button on there, it says CAS on the display and doesn't do anything. So I now have the schematics for this machine, albeit it's all written in Dutch, which is a bit unhelpful. I've been given lots of information. I've been told that capacitors in the power supply are a problem, that connectors everywhere are a problem, and that the mode switch underneath the deck is a problem. So we'll have a look at all of those, I think, probably starting with the mode switch. So let's get started. I've already taken the screws out. Let's have a look. Although the priority is to work on the deck itself, I am still a bit worried about this problem over here with the clock not setting and buttons responding slowly. So I'll just spend a few minutes seeing if I can bottom out what's happened there. If you'd seen part one of this video, you'll have seen me take this panel off, change the battery on here, and when I put it back we had this problem with buttons working slowly or not at all. So I'll just take this off again and have a look and see if there's anything unhappy. I'm going to go over this with a microscope and see if I can see any dry joints or similar. I'm going through all the buttons, whether I care about them or not, because it could be there's a problem with the key scan. If one button was jammed or there's some sort of leakage between tracks, that it would be causing the scanning not to work properly. I'm not seeing anything obvious, so I've been through all the buttons and they all work. The battery has gone flat, it's only 15 millivolts. I changed that, so the battery should be giving me a decent voltage. Don't think that's related to the problem, but I've charged it gently anyway. I just don't see what's wrong with this, and it may be one of the ICs has failed. I'll just have to reassemble it for now. Okay, I don't suppose that's changed the thing, so we'll work on this in a moment, but just to confirm we are where we think we are. Clock set, still not working. Okay, I'm going to eliminate some cabinet work and try the buttons just free like that. Clock set. It's working. So I think the cabinet work is jamming one of the buttons down, and that's what's screwing up the key scan. We should be able to reassemble it properly and solve that problem. This bit of board wasn't fitted properly. Let's just see if that had a bearing on it. Okay, try again. Yes, it's working. Aha, maybe that bit of board wasn't fitted properly. Okay, let's reassemble these, well, fit the screws and see if it works with the front panel installed. I know that's a small win, but you've got to take small wins with a V2000. Good. It still won't work, but we've solved that, and now we can work on the deck a bit. Okay, a quick check that it's all assembled and working now. So hit clock set, yes, 23, 24, and you go next, it goes down here from time to year, but it doesn't understand 2023. That would probably 2022 rather. Oh, it does apparently. All right, that's fantastic. Right, so I've set the clock, and I'm sure the rest of the machine doesn't work now, but at least that's not going to be causing the machine any confusion. So if I press eject, it will just say CAS and the channel number comes up. Okay, let's get the cassette, the mechanism out and see what's wrong with it. Okay, we have the deck out. I can just about get to the transport controls at the front here. Let's just take this off. From what I remember, it has some earthing wires which generally start to annoy you. These connections here. think you have to take this off. Yes, I remember now. Take this off with screws at the side. Well, not exactly screws, but something like that. Okay, I've got the top cover off. These are horrible things to refit. Just confirm that nothing's changed. Press eject. Nothing happens. Right, what we have here is the mode switch, if you like, contact set on the bottom of loading gear. I'm going to make sure those contacts are clean. They do look excellent, but I will put a bit of deoxit on that anyway. Now the loading motor seems to come through to this connector here, so I'll unplug that and I'll try applying a small voltage to see if I can get the mechanism to go through a loading and unloading cycle at all. I don't know what voltage it is, but let's assume about 6 volts. Don't know the voltage, don't know the polarity, don't know the current. Let's just experiment. Yes, that's running. I think that's gone into the laced position. Yep, mechanism is laced. So let's go the other way and see if we can go into eject. Okay, the mechanism itself is working. I'm going to reconnect that motor to the board, reassemble and see where we are. Okay, so when I power it up, it may close. It says CAS. Press eject, nothing happens. Try play. The mechanism is working. I don't believe there's a problem with the mode switch, but the machine is not driving the deck, just complaining CAS all the time. Right, I think at the moment we're probably not looking at a mechanical problem with the deck, so I'm going to connect to that motor drive again, close the cassette carriage and look at the power supply, I think, just to make sure we have all the correct voltages. I do at least have partial manual for that now. To that effect, we should have 12 volts on this connector F2 on pins 2 and 3. Let's see if that's in place. 1 and 3 are the same point and is reading 0.6, and if I press the button like play or rewind, just hits at 0.6 of a volt. So that's why we're not getting any activity on the deck. Right, we're going to have to go back and trace where that 12 volts comes from. So it's plus 12B, it says on the schematic. So pin 3 of F12, which goes off to one of these transistors, should be 21.8 volts. Nothing there. And pin 1 is our 0.6 of a volt, I should think. Yes. So we're on the right connector. I'm surprised there's nothing there feeding this transistor then. Have we not blown a fuse? 6 and 8 are the fuses that drive that rectifier. Those fuses are blown. Both of them. I'll check that rectifier. Perhaps it's gone all short-circuity. The time delay 1.25 amp according to the schematics. We'll definitely want to check that rectifier. Seems quite a low diode voltage, 0.2 volts, but is that right? It might be right. Looking at the output of this rectifier, just doing a resistance check to ground, and it looks just like charging up capacitors. So we could try it. I've replaced the two 1.25 amp fuses with 1 amp anti-surge fuses. It just happens to be what I've got in stock that I could find. Anyway, that's on the safe side. There's always a hazard they'll just fail immediately, but I think if there isn't a fault, we should get our supply voltages. So I will set myself up so I can measure what should be the 12 volt line on the output of this resistor here. I think I'll use a crocodile clip for that. Okay, we're almost ready for the great switch on. These are the two fuses. They may just light up and fail, or we may get our 12 volt line, which we'd see on here, and if we do, the deck might actuate a little bit. Right, here goes. Well, the fuses seem to hold, but I don't think I got the 12 volt line. Maybe it's switched off. Maybe I have to press a button to activate, to start the deck. So I'll do that again and press, well, I can't press eject because it's upside down. It won't like that. So I'll move it so that we can. Power up. There's nothing on the displays. What have I done wrong? I don't know what's going on. Let's check the fuses. Well, the fuses have survived. Let's see if the output of the rectifier gives us the 21 volts. Yes. So the 12 volt regulator circuit is either shut off or not working for some other reason. And furthermore, the display is not working anymore. Let's see if 5.1 volts is available on 5F6, which we did before. That's on here. You have 5 volts there? Yes. Don't know why the display's not working then. There's an on-off line that switches this whole system on and off. Okay, there's a couple of difficulties here. The IC we need to look at is marked on the diagram 7005, but actually on the board layout it's 7006. So there's a mistake. And it's buried deep under this heatsink. So I'm going to have to reassemble this at least partly and then take that heatsink off and see if I can get to that IC and measure some of the voltages around there. Can't help wonder why it is that now that I've got that, at least one of the supplies partly working, you know, this 21 volts is now present, why the display has gone out. It just doesn't make sense. The entire display I think has gone out. To prove that again. No, nothing. So the machine looks dead, but it isn't. Okay, so we've sprung the whole thing from the cabinet. Pin 7 of this IC 7006 or 7005, depending which diagram you look at, is supposed to be 2 volts, 2.1 volts. So we'll switch it on and have a look for that. I suspect it's not. No, it's not. So it's not switching the machine on. Unfortunately, when I was trying to do some measurements, it seems that these fuses have now gone open circuit, which was something that was very much on my mind. Presumably now the display will work again. Yes. Those fuses have gone. So there's some kind of intermittent short. There's something very terribly wrong with this 12 volt line here. I don't know what's going on, but it's intermittently blowing the fuses and it's all over the place in terms of voltage. Let's just see. I've changed the fuses for a moment again. Let's see if we get the output from the rectifier. Right. And we're seeing, of course, because we've got a high output voltage on pin 7 and almost nothing on the other side of this resistor 3014, we're seeing 20 odd volts across that resistor, which is clearly not what's supposed to be happening here. We should have 2 volts on the output going into the transistor. 7004, so I don't know what is wrong with this regulator circuit. Right, let's look at this power supply. There are two op amps in an LM358. Now I have to confess, I got a little bit confused by this, and I had to ask for a bit of help from people who are more familiar with these sort of circuits, and I'd missed the obvious. So the lower op amp, as I expected, is what does the actual regulation of this 12 volt line. There's a voltage divider and a zener, and as the output voltage goes up or down, that alters the relative voltage on pin 6 compared to pin 5, which will alter the output voltage on pin 7, which in turn drives transistor 7004, which in turn drives a PNP transistor, which does the regulation. But the top op amp confused me for a while, and it's because I kept ignoring a very low value resistor, number 3020. But what that's doing, that resistor, it is a current detector, so it drops a certain amount of voltage depending how much current the following electronics are taking, and if that becomes too much, then the output voltage on pin 1 will fall from its normal sort of 20 volt area down to the 0 volt area. It will via the diode BA317 take the transistor 7004's base down and switch off the regulator transistor, and it won't recover from that situation, so it will be tripped, and that is the problem we are having. So there is excessive current flowing from this 12 volt line. Now, very unfortunately, though the diagram implies that this 12B line just sort of comes off the board, off from this connector 1F2, it actually goes to other places, including this 11.9B line that goes all over the IF panel and tuner section. So finding where the overload is going to be hard. But initially I've got this 1F2 and 3F2 terminals which go off to probably the deck and other places. So if I spring those terminals, I can see if the voltage at 3020 recovers and that the regulator works. So initially I will just switch this on, and I think we will see the 12 volt line possibly blip up for just a moment before it trips out. So let's do that. Okay, well, it goes to 0.66 volts. When I switch the input off, you actually see a blip, and I think that as it comes out of tripped mode as the voltages collapse. So connector F2 has these two 12 volt connectors on it, pins 1 and 3. I will see if I can disconnect those. They are going to be down here somewhere. Let's find that connector. So here is connector F2. We're connected here to the 12 volt output from that resistor R3020, and pins 1 and 2 I think at this end. I'll check that in a moment. So let's see if we can disconnect. Well, it's pins 1 and 3 which are 12 volt output from this connector, and they snake off in this big black mess over to the deck over at this end. I'm not sure which end is going to be the easiest to disconnect. Well, one thing I could do, I suppose, is simply unplug this whole thing and see if, or I could unplug it this end and just confirm that 12 volt line comes back. Let's do that initially. Right, so with that completely disconnected, let's see if our 12 volt line works. 3, 2, 1, go. And, well, no, although it seems to recover from longer when I switch off the power. Do that again, power up, nothing much, switch off, recovers for 12 to 12 volts. So that, I think, means that the overload is not on there, but somewhere on this main panel. That's a pity. But it might be that as a result of having disconnected all of this, that we've got some other reason that that line is not, that 12 volt line is not on. So I think I will try just disconnecting pins 1 and 3 initially, if I can spring them off this connector. Springing the pins off this connector, which goes from here to the deck, is a little bit hard. This connector is built to specifically prevent that from happening, which I suppose is a good thing in normal service. So I'd have to cut the wires, which I don't really want to do, when I've already shown that the power supply is still in the tripped condition. So what I will do briefly is have a look at pins 1 and indeed 3, they're connected together here, at the load that they present just in a DC condition. So I'll just put this to ohms. So negative terminal connected to ground. What resistance do we see? Around 200 ohms. 60 milliamps. So that shouldn't trip anything, but it may be, of course, that as machine powers up, that the load becomes much heavier on there. But that seems very low, actually. Let's look at the load of this deck on those pins. Kilo ohms on both. Alright. So it may be that we can't do a DC test of finding this excessive load, but we need to find out whether, well, we could start with, is it the 12B line or the 11.9B line that's presenting the overload? And the way we could detect that would be to disconnect one end of the inductor 5001. The inductor 5001 is here. I have desoldered both ends. I'm connected to the 12 volt supply end with the other end disconnected. That should have taken out the 11.9 volt rail. So I'm going to power it up and see. I've still got the deck disconnected as well. So I'm going to see if the 12 volt line comes up on this multimeter. If so, I'll reconnect the deck and we'll see where this overload is. So let's start by powering up with that inductor removed. Still no 12 volt line. Okay, although it appeared momentarily at power down. So the overload is somewhere on the 12B line, but not the deck. Alright, we are still off in search of this overload. Let's see what resistance we now measure to ground on that line. Still about 200 ohms, even with that inductor removed and the deck unplugged. Now, I wouldn't have said 200 ohms is too low, but nonetheless, something's wrong. Right, so we need to go in search of other items on the 12B line. I think I'll reconnect that inductor so I don't forget to do it. Well, the 12B line does go onto this board here, which is part of the tuner system. It's IF strip, I think. And we don't even need that, so I can safely unplug that and see if the overload goes away. Except what looks like a plug-in board, I think is actually soldered. Right, so I'll disconnect the 12B line to that thing. That's not the 12B line, that's 11B line. So we need to find where the 12B line is going and disconnect it from some places. The tuner is connected to this 12B supply, so let's isolate that pin. Okay, I've isolated the tuner 12 volt supply, and my DC resistance has gone up from 200 ohms to 275. So not a lot, but I'm surprised that a tuner takes that much current. So let's set ourselves up again to measure the voltage on the 12 volt line. Okay, 12 volt line, still nothing. So the overload is not the tuner, but I think I will leave that one disconnected for a moment while I go in search of the overload. It also goes to the AFC unit. I need to go and find that and disconnect that. Right, the AFC is actually plugged in, I think, here. It's its own little circuit board. Might be able to just take that out of the IC socket. Okay, I've isolated this rather strange AFC module at pin 13 here, and we're still seeing 275 ohms to ground, so I really don't think that's going to make a difference, but we'll have a look at the 12 volt rail now. Make sure everything's safe. Okay. Still no 12 volt rail, apart from it shut down. So it's not the tuner or AFC. Keep going. Okay, I've hooked the oscilloscope up to this 12 volt line that we've been having all the trouble with. And I just want to show you what happens when I switch power on and then off again. I've got a very slow sweep on this. Right, let's power the machine up and then down and stop that sweep. That's the 12 volt line, and it gets to 2, 4, 6, 8, 10, 12 volts at the point that the power is collapsing. Seems a bit noisy, but it holds out there for, well, it's 200 milliseconds per division, so 300 milliseconds. Right, what can we tell from that? Apart from the fact this is noisy and I don't know why. If it's managing to hold the power for 300 milliseconds as the voltages collapse, then there cannot really be an overload on the 12 volt line. So the problem is in the op amp, or the circuitry around the op amp, which is detecting an overload. So I'm going to take a bit of a risk, maybe. I'm going to disconnect on that op amp. I'm going to disconnect the output of pin 1, which triggers the shutdown procedure via this diode. So then the 12 volt line should go up and stay up, and I'll also put a multimeter across the sense resistor, resistor 3020, and if we assume this power supply is capable of giving out an amp, and I'm sure it is, then with I equals V over R, we know the resistance. We should be looking, if we had an amp, at something like 0.1 volts across that resistor. If we get a great deal more than 0.1 volts, then okay, there's a heavy load. But if we get much less than that, then it's telling us that the load is low and the shutdown circuit is firing when it shouldn't. So let's hook that up. Okay, let me tell you what I've got it set up now. Pin 1 of this op amp, which can shut down the power supply, is disconnected. We have this meter looking at the voltage across resistor 3020. If that goes over about 100 millivolts, we're drawing more than an amp, which is possibly excessive, especially with the deck presently disconnected. This little multimeter here is just looking at the 12 volts output from resistor 3020, so I'm expecting that to go to 12 volts. If it goes over 12 volts, I'll be shutting the power off in a hurry. So let's see what, if anything, happens. Wish me luck. Still nothing. So the power supply remained shut down until the very end. Yes, pin 1's isolated. So why is that diode still apparently shunting out the voltage from our transistor? Or is there some other path that's grounding transistor 7004. Let's do some voltage measurements when we have power on. So we need to look at the base of transistor 7004, which is supposed to be at 12 volts but seemed to be getting shunted down by something. According to the manual it should be about 2 volts, but I'm sure it's going to be much lower than that. Yes. But it blips up to 2 volts as the power decays. So what's forcing that voltage low? It does not appear to be this this op amp, and we could look at the disconnected pin 1 where it's got the diode and confirm that that voltage is not low. 20 volts as per the manual, so that's not the problem. In fact, I'll resolder pin 1 at this point, I think. Okay, and confirm that again, that pin 1 is at 20 volts as it should be. Yes. So transistor 7005, is that conducting? What's the base on that transistor? If it's over 0.6 volts, that will be why it's conducting. It's 0.7 volts, that's conducting. If that's high, that would be why the transistor's off. So let's look at collector of 7018. Yes, 4 volts something. Okay, I'm going to take a step back because I'm seeing different results than I was seeing earlier. So what we have now is this multimeter is connected to the 12 volt line that's only momentarily appearing during power down, and this is the on-off signal. And this was working, I thought, earlier on, but is not working now. So if it goes high, 4.2 volts, then that's off. If it goes low, a few millivolts, then it should switch this on. So let's just momentarily confirm that. Exactly right. So we need to find out why that on-off signal is missing, or why it's set to off. Well, of course, the only thing that's changed, I think, since I last tried this was I have disconnected the wiring loom to the deck. So I'm going to reconnect that big multi-way cable to the deck and just check that doesn't make a difference. Okay, deck reconnected. That's on the on-off signal. That's on 12 volts. It ran. Now that's off, but that's correct. So if I press the eject button, power it up and press the eject button, will 12 volts come up and will it eject? Here goes. Wish me luck. It ejected. And close it. It's doing some slightly odd things because it's doing stuff it shouldn't be doing with the cassette not in there. But it's powering up. Why the difference? I don't know, but I think what I'll do is put this back in the case and then we can do some more testing. I've briefly reassembled it insofar as I've dropped the main board back in here and dropped the deck in there, but it's not got the screening shields on it and it's not been screwed together. It's just plonked into place. Let's see if the machine is still alive. I wouldn't be at all surprised if it isn't, knowing how finicky it is. Let's see. Power it up. Huh, nothing. That just doesn't surprise me at all. So I suspect it's tripped again in this power supply. And the way we can tell is if pin 1 of this IC is not at 20 volts. I think I can just about get to that pin. Okay, let's see if we get 20 volts on that pin in the untripped condition or low voltage, which means it's tripped. Oh, we do get 20 volts. Okay, so it's not tripped. Our problem is a on-off signal then, which is a little harder to get to. Why did it work momentarily? So I bet it's high. I bet it's at 4.2 volts. Yes, it is. So that's the off signal. Okay. And if we select eject or something, it'll stay off. Well, we need to find out why that on-off signal is off. So we need to find out where it comes from. Quite likely the front panel. Regular viewers will know I've been working on a Philips VR2324 V2000 video recorder, and I got stuck. I got terribly confused because I made one small mistake when reading the schematic diagrams. So let's see what I did wrong and see if we can make some progress fixing it. So this is a signal I got confused by. It's pin 5 of connector F2 on the power supply and RF panel, and it's described as on, and it goes into some transistors that allows the machine to switch on. And it comes from the main deck, one of the PCBs on the main deck, and it appears at pin 5 of connector D4, and I was following it through from the automatic tracking here on the circuit diagram. But I completely missed something really important. It's got this number 26, and that means this is a bunch of cables or bunch of tracks, and this is the 26 one. Do not follow it through to number 52 on the other side. That is an unrelated signal. So it's got nothing to do with the dynamic track following. So I have to go and follow this number 26 signal and see where it goes on the schematics. And it actually appears elsewhere on the same schematic, here as an on signal, where it comes out of an IC 7451, but could also be pulled low by 1453-2A, which is a hybrid circuit, and it generates a reset pulse. It could also be pulled low by back to the power supply and RF panel here on a signal RES bar, which is sort of low for reset. And if you look at the arrows here, it says it can both reset and also be a reset signal, so the arrows go both ways. So to isolate that, I disconnected the pin here at 1DE4, and the signal from this reset was high, so that is not the reason for the low reset. It's apparently from this 1453-2A. It can't be as a result of this analog to digital to analog converter, because that's on the other side of a diode. So if this is low here on this pin 18, then that is dragging the signal low. So I suspect that 1453-2A is at fault, but that's a hybrid circuit, so that's awkward. What are we going to do about that? Well, taking the board off the deck, here it is. It's got bodge boards on it and all sorts. This is most unpleasant. And here is our hybrid circuit, this one here. Now that would be very hard to take off, though I may have to, because this is a double-sided PCB, so taking all the desoldering it is going to be really hard. But anyhow, I have, if you remember, some scrap portable machines, VR2220. So this one I can use as a parts machine. I'm hoping it'll have either the same hybrid in it or possibly the same entire PCB, which would be easier to swap out. So let's take a look in here. So here's our VR2324. I've got the mechanism upside down there just to work on it, and I've disconnected all the connectors from this PCB. Let's do the same here with the portable. Right, so here's the board from the portable. Oh, that looks completely different. Oh dear. So I'm not going to be able to swap the whole board over, but does it have this module here which generates a reset pulse? A bit hard to tell. Part numbers are hard to get to. But looking at it, this one here physically looks very similar to that. So I'll check the numbers, and if so, I'll find a way to get that out from here. But having now seen that it's so different, this board, I'm going to do some more tests on this one before I start removing that, because it's a bit nightmarish to remove. I need to be extremely certain that that is the cause of the problem. Right. But I will get this one out ready for substitution if required. Something strange happened earlier on. You remember I have obtained this module from the scrap deck, which I hope is the correct one to go in here. It would go that way round. But I really wanted to isolate the output from the rest of the machine. So I tried desoldering the output pin of the reset signal, which is pin 18 here. I didn't have much luck desoldering it. It was just impossible because it's double-sided and there's only a blank land on this side, and I think I actually lifted the pad, but it doesn't matter because the actual track is on the other side. But I'd heated it up with my soldering iron in attempting to do so. I resoldered it, and the thing is, when I switched power back on to measure the voltage on there, not only did I get a high voltage, about 4 point something volts, but the machine sprang into life. Let me just try that again. No operation. But that says to me that the soldering iron heating that module made it spring into life. So I think that is very much pointing towards it being the module. But let's just try, if I can get some access to this, let's try a little bit of hot air to see if I can instigate and clear the fault with heating and cooling, just to prove that that is the cause. Now, access on this board is awful. That's about as much access as I can get, is just like that. And the module that we're interested in is, I don't know if you can see them here, the back one of these two. So can I get a little bit of warm air on that and see if we can instigate and clear the fault? Okay, so it's not working now. Let's try a bit of warm air. So I've set my hot air gun to 120 Celsius. So it's hot enough to make a difference, but not hot enough to do any damage. I'm just going to warm, well, I can't help but warm both of those modules, but let's see if I can warm the one we're interested in here. So the rearmost of these two modules here. Okay, so I've warmed it up. Let's look at this voltage on this reset pin. It just fired up. I had it in the wrong range. So the machine just started up then, you heard it. And this reset voltage is at 4.55 volts. As a result, I believe, of heating that module. I've powered it down again. Just try it again. And you see the displays are working. Try a bit of freezer on that module. Right, powered down. Freeze it if I can get to it. Okay, it's cooled down. Let's power it up. Looking at that reset voltage. Aha, low reset voltage and no deck operation. And no power supply. No displays. Do you think I've fairly well proven that that module is the cause? Okay, this is our board and this is our suspect module. And here is our replacement, we believe. It certainly looks the same, but I still haven't been able to read the part number on this to confirm it, and I'm not sure I'm going to have access to do so, because the part number's on the this face here. All the digits that I can see do match up, so I am going to start removing this, but it's extremely dodgy because one small mistake and I'll lift a track and wreck things, so it's not easy. I tried, when I came to remove this one from the scrap board, I used the desolder pump, but that had limited success. It helped a bit, and then I always used a conventional soldering iron and also the hot air gun. So I'm going to have to sort of do the same sort of thing to try to take this out extremely carefully. Now, it might be nice when fitting the replacement to fit a set of turned pin sockets in there so I can plug it in, but there's insufficient height on the board and it would not fit if I do that, so I'm just going to have to solder this in. So here is the output pin here, number 18, which you can see I desoldered earlier and kind of maybe lifted a bit of pad. So that's pin 19, 18, and then only certain pins are populated. So 17 and 16, and there's a large gap, and there's a few more further down here. So I need to desolder these and try as far as possible to clear the solder out of the through plate holes, which is extremely hard. It would seem that in my attempts to lever the module off, I've shattered a resistor, so I'll have to replace that. 22k resistor there, looks to be damaged. At long last, we've got that module off, but we've got a lot of cleaning up to do on the board. Okay, I think this board is now ready to accept the replacement module there. So I've cleaned out all the holes, I've replaced the resistor I broke, I've put in a tiny piece of wire to patch out what may be a failure of the through plating hole on, of all pins, the output pin, the reset pin, the one that's really important. The one more thing I will do though is just check the timing capacitor. I did check it in circuit, but it'd be better to check it with the module now replaced, or removed rather, to make sure that the 6.8 microfarad timing capacitor for the reset signal is in good order. Right, let's measure that capacitor. Oh good. Time to fit this module, which came from a scrap machine. Let's hope it's a good one. Okay, I've installed the module there. I left it very slightly proud of where the original was, so that I could get a meter in and check that every pin is connected properly to its land. So all the connections are made. Good, we can reinstall it on the machine and see if it helps. So it's installed, we are ready for the great switch on. Let's see if the machine clonks and the lights come on. Here goes. No, it didn't. Let me look at that reset voltage. Okay, switch it on. Low voltage, 0.3 volts or so. After all that work. So either I've done something wrong, or there's another part that's really at fault, or I've fitted a bad replacement module. Oh dear. Let's try warming that area again. Okay, I've heated that module up. What happens now? It powers up. So I'm in the right area. Maybe I've just got another duff module, or maybe I've got some other component wrong, but at least I know I'm in the right area. I think I'm going to assume that the power on reset circuit has a design fault on these modules, and the replacement one I fitted is defective. So I'm going to stop wasting my time with those. I can isolate the output and build my own power on reset circuit. The only slight difficulty being I don't know if it's an open collector output, but I suspect not. Looking at the diagrams, I don't see any reason that that would be an open collector output. So I'm going to use well, my preferred choice would be a 74 LS13 or 14. I only have a 7413 to hand, so that's not an LS part, but I'll build the circuit with a socket. Now, it's not necessarily going to be the most wonderful power on reset circuit. This design has flaws in the case of supplies that are extremely noisy, but they shouldn't be extremely noisy because it's got lots of capacitors on it. So I think we're going to build a basic power on reset circuit, get roughly the same time constant on it, and inject that where pin 18 is and isolate pin 18 from this module. So let's build that circuit and see if it fixes the problem. Well, here's my power on reset board. Now, I might say, bodge board is none too pretty, but given that there are several factory installed bodge boards, I suppose one more isn't going to matter too much. I did have to make sure that it will fit down into that space because there's not a lot of room on this board, so I'm going to sticky pad that down. I'm also going to label it, and then we'll see if it works. Okay, let me show you what we've got here, and I do hope this works. So this is our power on reset circuit, which is replacing this part of the module here. It's a sort of hybrid thick film module. So this has our 7413. I've decided against changing that to a LS 74 LS13 because I had to experiment a bit with the timing value for the capacitor and resistor in there, and I don't want to change that by altering the input impedance of the component, so we'll leave that as a 7413. So that has supply and ground and an output. Now the original output reset output from here comes out on a track here which I've cut, and I'm going to zoom you in a little bit so you can see that. So I've cut the track about here, and the output from the power and reset circuit actually goes off to this resistor. This is the one I accidentally crushed earlier on. So I'm just going to confirm that we have contact between the track which goes off to the reset circuit and this resistor point here. A little bit hard to see, but this resistor, this point on this resistor is the other side of the broken track. So I've soldered the output wire from this circuit to that resistor, and it also picks up a ground. That was quite easy to find, and the supply pin, which I think was pin 8 of this module, 5-volt supply, goes to here. So by fitting that, hopefully that will take the place of this. The reset, the time signal I've set on this, the period, the original one was about 70 milliseconds, it says, according to the diagram. This one is somewhat longer because it's better to be on the safe side, so about double that roughly. Right, let me zoom you out again. The other thing that was important was to find a space for this that doesn't increase the height. Now this is Philips' their own original bodge board here, so my bodge board is sitting nearby, and it should sit down and not be higher than the rest of the board. So that will hopefully not interfere with anything on the deck, no more than other things do. So we can refit that to the machine now, and hopefully it will carry out the reset signal properly. So here's the deck, which is presently sat upside down and with all the screening cans off. So I need to reinstall that, which is always a little bit fiddly. I wonder if I should tie this down so it doesn't touch anything. There's nothing, I think, that it would touch that could upset, or I suppose it could theoretically get involved in this gear. So I'll possibly tie it down just a little bit. Okay, that's secured it enough for it to stay in place while I assemble it. Okay, we're ready for the great switch on. Let's see if the machine carries out a reset properly. Switch it on now. And eject. And I think we press play to make it go down. It's going into play mode without a tape in there, which is a little odd. But other than that, we seem to be making huge progress. Eject again. Alright, that's a lot better. So we've solved the reset problem. Well, the Schmidt trigger reset, power on reset circuit works a treat. So if you're anything like me, you can't wait to get stuck in and try taping this machine, but I think I've got a little bit more reassembling to do first. So do please come by to watch me do that and work on other equipment in the near future. Bye for now.